Welcome back to part 5 of this ABAP Object Oriented tutorial series. And I think for this last part, we really saved the best for last. And that's the concept of inheritance. And it combines several of the concepts that we've already learned. Um, instance, the concept of an instance of a class, but also the idea of visibility, and as we saw a little bit with exception handling, this idea of inheritance. So classes, when we create an instance of the class, they can take on different variations of the same core idea. And this can be a very powerful concept. So we can inherit certain traits from a parent, but then become our own unique version of that copy. And a lot of times, this is a little bit of an overwhelming concept at first, admittedly, and it takes a little getting used to. But if you think of it in a parent-child, as in human beings, a child inherits certain genes from their parent, and that gives them attributes that are the same as their parent, hair color, eye color, for instance. But there are things that are different in a child. They don't act the same way as their parent. So they take on new attributes sometimes that their parent didn't have. And that's not a perfect perfect analogy. Actually, a lot of times the analogy of cars are used. You can have a certain type of car, automobile, truck, and there are certain attributes of a vehicle that are always the same. Vehicles all have steering wheels. They generally have four wheels. They have doors, but different types of cars. A truck versus an automobile versus a sports car could have very different attributes. They're still all fundamentally automobiles. They have certain core characteristics that are the same, and there's no reason to repeat the definition of those things. It can just be inherited from the more general definition of the object, but at the same time they need to override and have certain unique characteristics as well. Well, let's apply that same concept to our flight database. We have data about our flights, but you can imagine that all of us have probably taken an airline flight in our time. There's different types of airplanes out there. There's a very different experience between getting on a little, 3-seat row puddle jumper, regional airline, as opposed to getting on a giant 747 jumbo jet. Okay, they're still both airplanes. They both fly, so there are certain characteristics that are going to be the same about both those types of planes, but due to the nature of their size, the speed that they can go, the amenities that they can offer, there's pretty drastic differences between a flight on a 747 and a much smaller airplane. We want to apply the same concept to our very basic class where we're calculating the price. Today what we do is we create an instance of the class, and all the instances are the same class. They're all cut from the same template. Now they do have different logic based upon the plane type. 747s are getting a larger surcharge, a $40 surcharge, as opposed to all other planes are 10, except the A310-300 is getting a $25 surcharge. But instead of this if logic inside of our class, maybe we could do something different where we use inheritance and change the logic of the class depending on what type of flight that we have. So what we want to do here is we want to start with a base class. All right? So this is going to be the airplane class. This is going to be the things that are the same regardless of what airplane type is going to be processed. And what we see here is the constructor is always going to be the same. We've seen no variation in the logic of our constructor, regardless of if it's a 747, an A340, or an A310, or any other type of plane. We're going to have the same constructor because all we're doing is selecting a record from the database using the carrier ID, the connection ID, and the flight date, and throwing an exception. Okay, so we don't need any variation of that logic, so let's put it in our base class. Now, we do want variation in the way that we calculate the flight price. So what do we want to do here? Our base class is actually going to be an abstract class because the base class doesn't represent any type of plane yet. It's just the starting point, the blueprint, if you will. It's not, when you create a blueprint for something and then you create objects off that blueprint or off that template, they aren't the template itself. The template itself doesn't become something. It's just the starting point. And that's what an abstract class is. It is a template. All right? And what we want is we want this template class to be able to have the constructor, obviously. We also want it to be able to instantiate the child classes, the more specific classes, in a controlled manner. So what we're going to do here is have logic for the actual class name here. So they're all going to be named ZCL 00 tutorial 6, but then we're going to take the actual flight type and we're going to put it on at the end of the class so that we can create specific subclasses for the processing based upon the flight the plane types, and we'll even put some logic in here. We'll create constants for them so we're not hard coding the values and things like that. And we'll go ahead and even create the get flight details and get flight price, but we're not going to implement those. We'll create a base implementation, right? The parts that are the same, but we're not putting all the logic for the different flight types. We're just putting the very basic information in here, and we'll see in a minute how we can then override that with the more specific processing using the other class types. Okay. Now, the other thing we see in the here in the get flight object, so we have really changed the constructor around. We've moved the logic that used to be in our constructor to this get flight object. Well, get flight object is you'll see it here is a class method. So we're going to use a static method, and it's going to return an instance of our class. We're not going to call the regular constructor because we want to mutate the actual instance on the fly. So we're going to give it a type ref to base, but that isn't actually the instance, class instance that we're going to return here. That's just the most general way to describe the instance, that we're going to start with the base. But in reality, what we're going to do is, depending upon the plane type, is we're going to create a different class name, a more specific class name, and we're going to create that object inside of here, and that's what we will return out of our class. Okay. Now let's look at one of these more specific classes. So we have an A340. Let's look at it. And you notice here's our class for the A340 type. It inherits from the base class. So you're going to take on everything of the base class. It also has a friend relationship with the base class that's going to give it access to even the private parts of the base class. So it's going to have a special kind of relationship with the base class, and what we're going to see here is we're going to have the flight price, but we're going to say redefinition. So we're going to override the original definition. And let me pull this up once again side by side here. So this flight price. All the other methods are going to come in automatically, like the get flight details. We don't need to change get flight details. There's nothing different about it at this level, so we'll defer to what's in the base class, but we want to override and change the flight price. Well, in this case, we're already adding 10 on there. We'll call the original get flight price, that's super. So instead of me, we're calling super. That means it's going to call the class higher up in the hierarchy. So all the base logic will still be processed here. And then we'll tack on our additional surcharge that we need for the A340 plane type. If we look at all other plane types here, we'll see that they don't really need to do anything. They're going to inherit everything from the base class. There's no redefinition. It's just the specific class that can be instantiated for all other plane types. So that's really straightforward. And then we'll look at the 747. If we look here, now we have our 747 class. And this is really interesting because not only do we inherit from the base class, and we have our redefinition of the calculate flight price. We add on our higher surcharge, our additional 35 for the 747. That's fine. That's just like the A340 did. But we're going to further enhance it. The 747 is the only plane type in our fleet that has in-flight movies. So we're going to add additional method here that the base class, all the other airplane types don't have. An additional method here of get in-flight movies, and also some data processing here, a type for handling the movies. But when we call this method, it's also going to we're going to populate some movies. Now, we didn't bother with putting them all in the database and doing a select, but we're going to override the constructor here as well. We're going to redefine the constructor. We're still going to call the original constructor from the base class, get all the original processing here to get the flight details. Then we're also going to pop in 2 possible additional movies. Okay. Code's a little old. These were popular movies 10 years ago. I didn't bother to change the actual movie names or running times. I thought that was fun to keep that from 10 years ago. But now we've got the get in-flight movies, which is just going to return the 2 movies that we've populated in the constructor. So not doing anything all that extensive, but we can see how not only can we override the logic, but we can add whole new methods that are specific to only certain variations of our class. So we see not only is the data processing mutable, but the class logic itself is mutable, and not just in a way that we can override, but we can add to what's already there. Now, this gets super interesting when we start looking at our tester. So let's pull that up. So in our tester class, we're going to select from the flight table for all the United Airlines flights. Then we're going to loop at that internal table. And for each record in the database, we're going to create an instance of our class. But now we're not doing the new and the class type. We're calling a static method of the base class. Get flight object, we're going to pass in our keys. But remember this logic here? It's going to create the class for us of the more specific type based upon the data that was read from the database. So sometimes we're going to get 747 class instances, sometimes we're going to get other, and sometimes we're going to get A340s. And then when we call the get flight details, we're going to be calling the processing of each specific class type. And we're not going to have if statements in one method. We're going to have redefined versions of that method being called automatically. Our calling program has no idea that there are different class types. It doesn't need to know there are different class types. It's just going to call the flight details and the flight price calculate, and automatically the correct version of the class, the correct instance of the class, will use the corresponding correct logic. We can also see here, if we check for the plane type, and we see that the plane type is 747, oh, if it's the 747, we need to get the movies. And we can call the get in-flight movies. But to do that, we need the more specific version of our class. Because up to this point, our flight object is just the generic type, the base type. And that method wasn't defined in the base type. If I were to just call the flight object get in-flight movies, well, that would throw a syntax error. It would say, well, that's not right. So I'll try that here. I'll show you this. So if I just say flight, that's our table. Where am I at? Oh, no, that's our internal table, and then we get our sorry. If I just call flight object, and I try to see, it doesn't show in the value help here. If I say flight object, what was it? Get in-flight movies. Of course, that doesn't work. In-flight movies. Oops. Syntax error. Would not activate. Get in-flight movies does not exist. The following methods with similar names. That doesn't work. But why then does flight 747 work? If I change this here to flight 747, no syntax error, right? And even if I do the value help, now I see get in-flight movies. Well, that's because the ABAP compiler here knows that I have now cast that instance to the more specific type. I've taken the flight object, that's our generic instance, and I've said cast that into the more specific type. Now, of course, that only works if it's actually that type. That's why we have to have the if check to check the plane type around it. We'd get an illegal cast if it was actually an A340. That would throw an exception. But as long as it's truly of that inheritance, this is going to work, and then I can call the flight movies, and I'm only going to call that method for the ones that are 747s. So let's go ahead and run this. We didn't actually make any changes, but let's say run as console, and what we see here, our prices are being output. Here's a 747, and notice when we have the 747, we also get the movies being output. Here's an A340, and it's, I mean, we'd have to look inside the logic to see that it's using the different calculation. Where this gets really interesting here is, let's go ahead, let's put in my dummy code. This time it should work. 0, diff, activate that, set our breakpoint. And let's look at this in the debugger now. Let's switch. And what we see now is if we look at our flights, oh, actually, not putting that into the table. I should have done my breakpoint elsewhere. Sorry about that. That was my earlier example where I was putting it in the internal table. We could have done that as well. We could have put the instance back into the internal table rather than a particular variable here. That might have been a little bit more elegant of a demonstration, but that's fine. We'll work with this. I'll put a stop here and we'll see our flight object. First one is initial right now, so let's just focus in here on flight object, and each pass of the loop we're going to see it. Right now it's initial. If we do a step over, then we see it's been initialized. So the first one is an other. So the debugger sees the specific type that was created, even though the general type here, we see the technical type that was declared via the code was tutorial base, but depending on the logic of this getFlight object, it's actually creating more specific objects. Even though our code references it as the base general object, what the debugger sees is the more specific object that was actually created, so other. And let's go on to the next loop, and we'll step over. And now, on the second pass, we hit a 747. So our technical type is still base, but what's in memory is actually a 747. And therefore, when we drill into it, we see it has the movies object, right? And we're able to cast and see the movies there. And if we would continue on, let's go here to the next one. Let's step over the flight object, and now the flight object is an A340. It's still a base, but it is the more specific type. And and when we look into that type, now our movies are gone because that type doesn't have the movie. So we see how we have a very powerful, flexible code structure here that can take on different attributes, different logic based upon inheritance, but still have a lot of core logic coming from the base. We don't repeat logic over and over again for these different types. And the other thing that I want to show you very quickly here is we go into the base class. Let's say tomorrow all the upcharges need to be increased. Well, we don't need to go into the separate classes to do this. If the base charge is going to increase, let's say it's a huge increase, it's 100, and I go to the base class, and I increase the base charge, all the subclasses are now inheriting from that. They all have the 100 charge. So if we were to run this again in the console, we didn't probably look terribly closely at our prices, but if we were to study those offline there, we would have seen, let's get rid of our breakpoint. We need to see that. Are, and you kind of have to take my word for it. I mean, we could go into the debugger and see it in detail, but now all of our prices are 100 higher, regardless of the type, because of the logic in the base. So we can see here by common logic not being repeated, we can change it in one place and it immediately impacts all the subclasses as well. This is a very important concept. So we've seen the base concept of inheritance. We've seen what is called polymorphism, the ability for child objects to take on different structures, different attributes, the redefinition, the additional method. So we've seen some of the most common concepts of polymorphism as well. These are some big names, some big words, but hopefully this has helped made real the concepts that we're talking about here, and really one of the most powerful aspects of object-oriented programming, that if you're really just creating static classes with static methods, you're not taking advantage of the real power here that comes from visibility, instance classes, and most importantly, inheritance.